Hi pre-calc students. Today let's start off section 9.2, part 1, graphing ellipses notes. So an ellipse has two vertices, also two focus points called foci. If you were to connect any point on the ellipse to both focus points, the sum of the two distances is always a constant. Here's an example of what an ellipse can look like. We can see ellipses in different ways. This would be an example of a horizontal ellipse. We can also have a more vertical looking ellipse. Before we get into it, let's talk about our equations, okay? So the equation for a horizontal ellipse, like the one you see here, is x minus h squared over a squared plus y minus k squared over b squared equals 1. This is a horizontal ellipse. And the equation for a vertical ellipse looks kind of the same, except for A and B switch places. So the vertical component, or the a squared, is underneath the vertical component, or the y. And so a horizontal ellipse looks like what we see here, and a vertical ellipse looks like this. However, regardless of whether your ellipse is vertical or horizontal, the center of the ellipse is at HK, like you see here. The center is HK. And we have these things called major and minor axes, okay? So the major or minor axes are always 2A or 2B. So I'm gonna just write that down really quick before we start labeling up our diagram here. All right, so this is a horizontal ellipse looking like this, a vertical ellipse looking like this. Let's label up our diagram over here, okay? So this is our major axis, okay? A major axis of the ellipse. And the major axis joins the foci and the vertices. So for an ellipse, the major axis will always have the foci and the vertices on them. The major axis is having to do with the a squared component. So for a vertical ellipse, the major axis, or for a horizontal ellipse, the major axis will be horizontal. For a vertical ellipse, the major axis will be vertical. The minor axis is here. And this is always perpendicular to the major through the center. Let's look at some distances here, okay? So as you can see, we have an A value, a B value, and when we're talking about the focus points, we have a C value. C is the distance from the center to each focus point. In order to calculate that C value, we can use C squared equals A squared minus B squared. So let's label this up. From the center to a focus point, we have a distance of C. From the center to the edge of the ellipse on the minor axis, we have a distance of B. I'm not going to label both sides so it doesn't get crowded. And from the center to each vertex, we have a distance of A. So once we find the center, we find A, B, and C. We decide if it's vertical or horizontal. We can go ahead and graph this thing pretty easily. Let's look at our first example down here. It says graph the ellipse. Okay, so I noticed that I have a larger number underneath the y value here. That indicates that a squared is underneath y, and therefore this is going to be a vertical ellipse. So my center is at -3, +2. And I know that the major axis is vertical. A squared is going to be larger than b squared every single time. So if you see the larger number underneath y, that tells me it's a vertical ellipse. If you see the larger number underneath x, that tells me it's a horizontal ellipse. So in this case, I have b squared equaling 4, and therefore b equals 2. And I have a squared equaling 16, therefore a is 4. So let's go ahead and set some stuff up, and then we'll come back to find the focus points. So the center is at -3, 2. Let's go ahead and plot that. -3 over 2 up. There's the center. And now, since I know it's a vertical ellipse, I'm going to go ahead and plot a units away from the center for the major axis. And since it's vertical, that's going to be up and down 4. So I'm going to go ahead and go 1, 2, 3, 4, there's a vertex point, and 1, 2, 3, 4, there's a vertex point. Now to get the minor axis, I'm going to go 2 values away on either side, but since this is vertical, I'm going to be going horizontally with those units. So I'm going to be going 1, 2 away, 1, 2 away. So now I have the basic outline of my ellipse, and now I just want to find the focus points. One thing you want to notice about the focus points is that they are always inside of the ellipse. So when you calculate them over here, if they end up like outside of the ellipse, you've done something wrong. So in order to get those focus points, I have to find the c value. Okay, so c squared equals a squared minus b squared. So c squared equals a squared, 16, minus b squared, which is 4. That's 12. So c equals the root of 12. And notice the distance from the center to the focus point is c, which is root 12. So therefore, my center is at -3, 2. The focus points are at -3 plus, -3. And then I'm moving vertically here, so 2 plus or minus root 12. Well, root 12 is approximately, how much? It's approximately 3.5, okay, about 3.5. So when I actually look at these 2 points, I will have -3, -1.5, and -3, 5.5. So let's go plot these over here. -3, 5.5, it's close but inside, and -1.5, it's close but inside. So that is our first ellipse that we've graphed. Let's do one more. Okay, I'm looking down here at this equation, and I notice the larger number is underneath the x value. So that means the major axis is going to be running horizontally. Therefore, this is a horizontal ellipse. I notice that I have a center of -3, 0. And the major axis is going to be horizontal, like we said. Okay, let's go ahead and find out what a and b are. A squared is equal to 16, therefore a is equal to 4, and b squared is equal to 1, so b is also 1. So let's start out by plotting the center at -3, 0. And I'm going to run the major axis horizontally. So I'm going to move 4 units, 1, 2, 3, 4, 1, 2, oopsies, 1, 2, 3, 4. There's the major axis. And the minor axis, I'm going to move up 1 in either direction. It's getting kind of tight here and messy. And there I have the basic outline of my ellipse. Okay, I just want to add in the focus points. So the focus points, remember, c squared equals a squared, which is 16, minus b squared, which is 1. So c is equal to the square root of 15, and the square root of 15 is approximately, 3.9. Okay, So what I'm doing is I'm taking the center point and I'm moving, 3.9 on either side from that center point to get the focus. So what I would have here is -3 plus or minus root 15 comma 0. The height doesn't change, I'm just moving in either direction. And since the root 15 is 3.9, these points would actually be -6.90 and 0.90. And it's okay that they're very close to the vertices, it's just that they need to be inside the ellipse. So there we've graphed our second ellipse. Okay, your turn. Go ahead and try to graph this ellipse, pause the problem, and when you're ready, play to see if you got your answer correct. Okay, everybody, this is not my best drawing job, but the center is at 5, -1. I noticed that this is going to be a vertical ellipse because the larger, or the a squared value, is underneath y this time. A squared is 49, a equals 7, b squared is 4, b equals 2. I went ahead and found those focus points down here by plugging in c squared equals a squared minus b squared. C is root 45. We're moving in a vertical direction, so we're adding from the center plus or minus root 45, which gives us those focus points of 5, -7.7, and 5, 5.7, and I just make sure that those are within the boundaries of the ellipse, and they are, so that's good. All right, let's go ahead and move on to some practice problems. Let's do this one together just to make sure we know what's going on. So from here, I can tell I'm going to have a horizontal ellipse where the major axis is going to run horizontally since the larger number, the a squared value, is under x squared. So the center here is at 0, 5. That major axis is horizontal. A squared is 100, therefore a is 10. And b squared is 9, therefore b is 3. So I can go ahead and put down my center point at 0, 5. And I can move out the vertical axis 10 in either direction. The major axis, I'm sorry, I don't know if I said major or minor. And the minor axis, I'm moving up 3 and down 3. So now I have the outline of my ellipse. I just need to put in my focus points. Oh no, please don't make me draw this bad. All right, not too bad. And let's find what those focus points are. So c squared equals a squared, which is 100, minus b squared, which is 9. This is root 91 is what c equals. And so I've got 0, because that's where the center is, plus or minus the root 91 is going to get me to my focus point. So plus or minus root 91, comma, we're always going to stay 5 up. When I throw this in my calculator, I find out that this is -9.5, comma 5, and positive 9.5, comma 5. And it's okay that it's close to the vertex points. You just want to make sure it's within the boundaries of the ellipse. If not, something went wrong. All right, for the following problem, you try, go ahead and pause the video and then unpause to check and see if you got your answer correct. All right, as you can see, the a value is underneath y. That means we have a vertical major axis. A is equal to 6, b is equal to 2. Center is at -1, over 2 up. We move out 6 in the vertical direction to get the major axis. We go left and right 2 to get the minor axis. We found the focus points. C squared equals 32, so c equals square root 32. We take -1 and we move in the vertical direction away root 32 from that center. We get the focus points -1, -3.7, and -1, 7.7. They're inside of the ellipse, so we're good. All right, that's it. Have a great day. Bye.